Hello, this is Mr. Stansbury. I'm going to take you through the notes on finding a quadratic from its graph. At the end of this, you should be able to say, I can find the equation of a quadratic given its graph or multiple points. Okay, so the first one we're going to do is take a look at example 15. Find the equation of the quadratic with the graph. Okay, so we already know all the axes intercepts, which will make this finding this equation much nicer. Okay, so since the x-intercepts are negative 4 and 2, we know that y equals, we don't know what this number out here in front is yet, so we'll just call that a. We're going to figure that out here in a second. And we know that if the x here is 4, 4 minus 4 gives us 0, right? So that's going to be x plus 4. Sorry, that's negative 4 plus 4 is 0. And then over here at 2, so when the x is 2, what do we do to 2 to get it back down to 0? Minus 2. So we know that that's part of our equation here. Now we got to figure out what the a is, right? So when x equals 0, when these x's equal 0, we know that the y equals negative 2, because that's what it gives us for the y-intercept. So we'll do negative 2 equals a times 0 plus 4 times 0 minus 2. Negative 2 equals a times 4 times negative 2, right? So negative 2 equals 4 times negative 2 is negative 8a. Divide both sides by negative 8. And we get that a is going to be, negative over negative is positive 1/4. Okay, so then our equation we could simply write as y equals 1/4 of a plus 4. Sorry, x plus 4, not a. X plus 4 times x minus 2. Okay? Okay, let's try the same thing with b over here. We only have one x-intercept, and that's 3. So then that means we know it's going to be y equals a times, since it bounces at 3, that's going to be our double negative, right? So if this x we know is 3, put 3 in for the x, so we have to subtract 3 to get it back down to 0. So x minus 3 squared is what this is going to be. Okay, now we know that the y equals negative 9 when the x is 0. Right? So negative 9 equals a times negative 3 squared. Negative 3 times negative 3 is positive 3, so that's 9a. Divide both sides by 9, and we get that a is negative 1. So now we know we'll just put negative 1 in for that. So our equation would be y equals negative 1, or just negative x minus 3 squared. And those are our equations for these two quadratics. Okay? All right, next one, example 16. Find the equation of the quadratic with this graph here. Now, they only give us one x-intercept, and they give us the y-intercept. But here's the deal. We should be able to figure out what this other x-intercept is here. If this is negative 1, that's a distance of 1, 2. So if it's a distance of 2 this way, it's also going to be a distance of 2 this way. So that's already negative 1, negative 2. This here is going to be negative 3. So now we're just back to what we did before. We know that y equals some a times this x is actually negative 3 plus 3 gives us 0. And then this x is, next x is 1. 1 minus 1 gives us 0, right? And we know that the y-intercept is negative 6. We'll do negative 6 equals a times, whenever we're looking for the y-intercept, all the x's are 0, so we do 0 plus 3 times 0 minus 1. Negative 6 equals a times 3 times negative 1. Negative 6 is negative 3a. Divide both sides by negative 3. And we get that a equals 2. So now our equation from right here is going to be y equals 2 times x plus 3 times x minus 1. And it does not matter which one of these goes first. Okay, it can be either order, same thing. All right. Well, let's take a look at this one. But before we do this, let's take a quick little comedy break. All right. Example 17. Find the equation of the quadratic whose graph cuts the x-axis at 1 and 5 and it passes through the point 2, 6. Give your answer in this form here. Okay. So here's our two intercepts. So we get y equals a times x. So that this x is 1, 1 minus 1 gives us 0. And then this x here is 5, 5 minus 5 gives us 0, right? Okay. Now it's normally nice if they give us the y-intercept, but they didn't. They gave us a point now instead. But it's okay. It's still going to work out because this is our x and this is our y. So we know that when the y is 6, and then we know that the x has to equal 2. So now we do, instead of 0, we put 2 minus 1 times 2 minus 5. And then we solve this for a. Okay, so we get a. 2 minus 1 is 1. 2 minus 5 is negative 3. So we get 6 equals a times negative 3. Divide both sides by negative 3. And we get that a is negative 2. So now, from this here, we can write it as y equals negative 2 times x minus 1 times x minus 5. Okay? And again, what we did there is we know that when x is 2, y has to equal 6. So we just plugged in 2 for the x's, and we plugged in 6 for the y, and we solved it for a. Okay? Now it does say to write it in this form here. So what that means is we're gonna have to FOIL this thing out and just simplify it. So let's just leave the negative 2 on the outside first here. X times x is x squared. X times negative 5 is negative 5x. Negative 1 times x is negative x. And negative 1 times negative 5 is plus 5. So we get y equals negative 2 times x squared minus 6x plus 5. And now we can distribute the negative 2 through, and we get negative 2x squared plus 12x minus 10 would be the equation in this y equals ax squared plus bx plus c form. Okay? One last example, example 18. Find the equation of the quadratic function which passes through these 3 points. Okay? Now this is going to be really a kind of completely different thing here. We are going to take this and we're going to plug it into a system of equations, and this is 3 equations with 3 unknowns, but I'm going to show you how to do it on the graphing calculator. Okay, so here's what we want to do. Let's look at it this way. We know that when x equals 2, y equals negative 4. Okay, that's this one right here. So therefore what we're going to do is we're just going to plug this into the good old quadratic here. So we will do negative 4 equals, let's see, we'll go with a times 2 squared, right? And then we're going to do plus b times 2 squared plus our c, which we don't know. So look, we've got a, b, and c are all of our variables here. So really this simplifies to negative 4 equals 2 squared is 4. So that's 4a plus, that's not squared, that's just plain old 2, plus 2b plus c. Okay, so there's one equation. And this one here, when x equals negative 4, y equals negative 8. So we get negative 8 equals a times negative 4 squared plus b times negative 4 plus c. And then we just simplify this one. Negative 8 equals negative 4 times negative 4 is 16a minus 4b plus c. And on this last one, we get when x equals 6, y equals 8. So we do 8 equals a times 6 squared plus b times 6 plus c. So we get 8 equals 6 squared is 36a plus 6b plus c. Okay, now we have three different equations. And then what we would normally do, is three equations with three unknowns. You go through and solve it, and it takes a long time. But what we're going to do is we're going to actually plug it into our graphing calculator to solve. Okay, to put this in correctly into our graphing calculator, we actually want the a, b, and c to be on the left-hand side, and then equals the constant. Okay, so I'm just going to rewrite those all together here in the right form. Okay, so it looks like this. Okay, now what you do, graphing calculator, this should work on any of your TI-84s. It might not work on a TI-83 unless you have a certain program. So here's what we want to do, and we'll make sure that we get you this program on your calculator if you do not have it. Okay, so we go into apps, and if you'll notice right down here, number 9 is Poly Simult 2. That's the one we want. So probably quickest just to push the 9. Okay, so polynomial root finder, simultaneous equation solver, so forth and so on. We want to do the simultaneous equation solver, so we're going to go to number 2 and push enter. Okay, we have three equations, 1, 2, 3, and we have three unknowns, 1, 2, 3. Okay, I'd actually do several more than that, which is crazy, but anyway. And then we'll just leave all the rest of this stuff here, and we're going to do next, so that we have to push the graph button, which is next. And now what we got to do is we got to clear all this stuff out and put our stuff in. Okay. Wow. Okay. Really our best bet, don't even worry about taking those out. Just put the new ones in. So I'm just going to type 4 in that spot. That's going to go over the new one. Push enter twice because that's, you know, unless it's a negative, then we'd have to change that sign there. But this next one is positive 2, B, and then it is plus a positive 1c. So 1, enter, and then for this one we'll have to do negative 4, enter. Okay, and then it goes to the next one, and we enter all the rest of those in. Okay, so then we end up getting this all in there. It's important to note that on these here you push the negative 4, and on these over here you're going to push subtract. Okay, so then now all we're going to do is solve. So over here it says solve. We push that button there, and it gives us these terrible fractions, but that's what the x, y, and z are going to equal. So x is 7/30, y is 17/15, and then z is negative 36/5. Write our equation. It's going to be y equals, let's see, actually that's not x, y, and z, but a, let's get rid of those. This is a, b, and c. Okay, so it's y equals 7/30 x squared plus 17/15 x minus 36/5. That would be our equation. Okay. I will try to give you, when we do any of these, I'll try to give you ones that will work out a little bit nicer than those terrible fractions. But anyway, you at least now know how to do that on the graphing calculator, okay, which you get to use on your test, and you get to use on the IB test too. So we'll practice this some. If you have any further questions, please feel free to ask. Thanks.